Okay, I'm going to do a question similar to the last one on assignment 4, where you have to verify the derivative of a trig function. And I'm going to do a tangent. So essentially, I'm going to show you, using the quotient rule, that the derivative of tan x is equal to secant squared x. Again, very similar to the last question on assignment number 4. So we could let y or f of x equal to tangent of x. And we know that tan x is equal to sine x over cosine x. And what we're going to do now is find the derivative of this function using the quotient rule. So dy dx, or y prime, is the bottom term squared. It's the bottom term, which is cos x, times the derivative of the top term, which is sine x, minus the top term, which is sine of x, times the derivative of your bottom term. Again, you can actually do the derivative in this step if you wanted to, but I'm putting all steps in. So we know we're going to have cosine of x all squared, and we'll have cos x. Derivative of sine is cosine minus sine x, which is right here. Derivative of cos x is minus sine x. And that's the derivative done. Now we simplify it to get secant squared. And we know that cosine x times cosine x is cosine squared x. And negative sine x and negative sine x is a positive sine squared x over cosine squared x. I should point out, by the way, that cosine x squared is the same as cosine squared x. However, it's not equal to the cosine of x squared. And we'll see this actually when we look at the chain rule, which is our next unit. One thing you don't do is cancel cosines here. It's an algebraic error. And we know from the fundamental trig identity that cosine squared plus sine squared is equal to 1. And this is over cosine squared x. And the reciprocal ratio, 1 over cos of x is equal to secant x. So 1 over cos squared is secant squared. And I can simply replace cosine squared, 1 over cosine squared with secant squared x, and we verified the rule using the quotient. We verified the derivative using the quotient rule.